Hi everyone, Mrs. Basega here, and today let's talk about calculating total vectors, or an actual application for Pythagoras' most famous theorem. So let's say I have a situation where you and your friend are moving, and this is the top view of you moving a refrigerator. You put a 8 Newton force forward, and your buddy puts a 6 Newton force to the right. Now we can't just add them together. 6 plus 8 does not equal the total force. In fact, the total force is the hypotenuse of this triangle, a triangle with a side of 8 and a side of 6. So to find the net force, I'm going to take a look at this triangle that's formed. Notice that the 8 newtons could be transposed on the left side of the triangle or the right, and it doesn't make a difference. Taking my a squared plus b squared equals c squared, the two sides squared equals the hypotenuse squared. So taking the square root in this case gets the net force of 10 newtons. More closely, because 8 and 6 are the two sides of this triangle, I would use the Pythagorean theorem to find the hypotenuse. Hey, let's try it again with one you've seen before. Do you remember that problem where it was you and your friend, and you were each pushing a car forward at 500 newtons to the right? The car had a weight of 1,960 newtons down and a normal force of 1,500 newtons up. There was some friction in that problem too, if I recall. So if I want to find the net force here, step one is to calculate the net force in the x and y directions separate from each other. In the x direction, that means you pushing 500 plus your friend pushing 500 minus the force of friction gives 550 newtons to the right. In the y direction, gravity pulling down at 1960, subtract normal force pulling up, gives us our 460 newtons down. Now that negative sign, you can actually ignore it in some of the problems later because it will get squared away anyways. Next, we're going to redraw the free body diagram, and I use this to help show what angle is going to be there. So it's 550 to the right and 460 down. The net force then is down and to the right. An angle is going to always be defined from the horizontal. Step 3, Pythagorize it. Side 1 squared plus side 2 squared equals the hypotenuse squared. Or in this case, 550 squared plus 460 squared, all square root. Getting there. Square root it so we can get the net force. Gives us a net force of 717 newtons. Okay, but that's not quite it. So let's rewind for a second, and we're going to add one extra thing. If you want to challenge yourself, add step 4 to this problem. The net force has a direction, and you could just call it up and to the right. But if you want to calculate that angle from the horizontal specifically, we can use this equation. And this equation is always going to be true as long as you define your angle from the horizontal. Applying it, this says the angle from the horizontal is the inverse tangent of the length of the y-axis over the length of the x-axis. In this case, it's 53.1 degrees above the horizontal. Notice that the horizontal is where our 6 newtons is, and the 53 degrees is defined as above from that. Let's try that same inverse tangent equation as step 4 of our pushing the car problem. In order to find that missing angle, I would take inverse tangent of the y over x, or in this case, that's inverse tangent of 460 over 550. And make sure your calculator is in degrees for this. In this case, that gives me 40 degrees below the horizontal because notice it's down and to the right for our net force. Finally, let's do one example all the way through all 4 steps. Let's say in this case I have T1y pulling up and T1x pulling right. That 8 Newton and 3 Newton force are components of some tension force. T2 is a separate string applying a tension straight left. So let's find the net force in the x and y direction. In the x direction, 3 minus 2 gives us 1 newton right? In the y direction, 8 minus 5 gives us 3 newtons up. Step 2, redraw that free body diagram. 3 newtons up and 1 newton right means we've got a net force problem with Pythagorean theorem on our hand. Y is 3, x is 1, and so let's Pythagorize that. F net is equal to x squared plus y squared all square root. So that's 1 plus 9 all square root. And that gives us 3.2 newtons. And finally, for an extra challenge, let's use that angle at the end. The angle is inverse tan of y over x, so that's 3 over 1. Or in this case, that's 72 degrees, wait a sec, above the horizontal, not below it. In homework 1.3, the whole first page, front and back, will be involving this type of problem. Best of luck!